my name is Paweł. I work for Virtus Lab and I am the main maintainer of Kotlin plugin for Eclipse.
Why Eclipse? First question.
It's a job near the core of language. I think you cannot have a job closer to Kotlin core except for jobs in JetBrains. Yeah. Okay, so today I would like to talk to you about Kotlin not being just better Java, as it is often dubbed as. I would like to show you the language that can change the way you think about solving problems. But let me start with some small digression. In first half of 20th century, there was an American fire safety inspector named Benjamin Lee Whorf. He had very peculiar hobby. He was interested in languages of Native Americans. He later in his life contacted with Edward Sapir, who was a scientist studying Uto-Aztecan languages, and Sapir agreed to cooperate in research with Whorf. They created some informal way of thinking about languages that was later quite misnomed as Sapir-Whorf hypothesis. They stated that language in 100% determines how person thinks, and nobody can think about anything that it cannot express in any language he knows. They use example of Hopi languages. It is one of Native American languages. In which there is no grammatical tense, there is no any expression for before and after, and they concluded that Hopi people have not linear sense of time in their minds. So for them, time is not linear. That was quite controversial hypothesis, of course. For over half a century, linguists was arguing about it. But we are here not to talk about Native Americans languages. We are here to talk about Kotlin, programming language. But I think using some programming language can also change the way the programmer thinks. For example, I remember in my early years at university, there were classes of algorithms and data structures, and there were some classes about intensive use of recursion and dynamic programming. And every student that has any experience in functional programming languages was dealing with it really well. People can just come to Blackboard and write solution bottom to down, but there are some people who doesn't understand functional languages, who struggle even to understand what's going on. It was funny because code in these classes were not written in Haskell, it was written in pure C. So when someone knows Haskell, it changed the way they think in C. So for me, Haskell, when I learned Haskell, I understand that immutable state, pure functions is not art for the sake of art, but it is a useful tool that can be used to avoid many problems that are quite normal for imperative programming. The other language that learned me something was Rust. It is language with complicated ownership and borrowing system, some data structures can be owned only by one other structure or only by one other data structure, and they in other places they can only be referenced. It's called borrowing, and you have to explicitly state lifetimes of these references, so it guarantees in compile time that no pointer points to something that was already disposed. It seems like it doesn't have any use in languages like Java and Kotlin where we has garbage collecting, but I realized that after learning Rust, I began to structure my program slightly differently, and I still have somewhere in back of my mind the concept of ownership, and flow of my programs become more predictable, more clean and easy to follow. But Haskell and Rust are rather revolutionary languages, and Kotlin is something more evolutionary. So what can Kotlin change in our way of thinking? I think there is some subtle questions, but let's start with something that will be really alien and exotic for Java programmers or other C-like languages programmers. In Kotlin, return is an expression. It's not statement. I will show you. You can write some function called create. It has some value called info. Its type, I found Googling most ridiculous Spring class name. So you have this bin context service provider bin info, and you assign to it return 5. And it's 100% proper Kotlin. It will compile, it will work. How I will talk about in the moment. But not only return is an expression, also throw is an expression, so you can assign throwing an exception to value. Also, if is an expression and try is an expression, but you can ask, Kotlin is type-safe languages, so where here is this type safety? What are even types of this expression? So let me start from the bottom. The last one is quite easy. You have some function that read int from somewhere. So okay, in this branch you just return that int. Then you have a catch branch that catches IO exceptions, and it returns 0. So one branch is returning int, the other is returning int, so it's quite obvious that x will be int. Okay. The one with if is, I think, even easier. There is some condition that is checked. If it is true, it's 10, else it is 0, so it is also int. But what about this one with throw? The first thought would be it is type of assertion error, but then why is it throw there? So it kind of doesn't make sense. The first one is even more strange because it contains some declared type, and we just assign result of this return expression to this val. So something that is returned from return expression must be assignable to this class, bin context service provider bin info. So it must be its subclass somehow. But as you can see, we can put whatever we want as a type of info. So it also must be subtype of string, of array, of int. So what it can return? In other ways, we can look at it as in imperative languages, when you put some instruction after the throw or after the return statements, they are never executed. It's the same in Kotlin. In Kotlin, this assignment to x and this assignment to info are never really executed. So this expression returns nothing, and nothing is typed in Kotlin. You can just create a variable with type nothing. I will in a short while tell you how to create it. it has some interesting properties. The first one is it is subject of all types. So so all these statements are correct, are proper compiling Kotlin. Oh, I see I have mistake. This variable at top should be called nothing. So you can assign this variable to something of type int, something of type string, and array. Moreover, it cannot have any instances because there is no object that you can assign to all types. So it must be only type but no object. And it is a return type of all functions that can be proven to never return not exceptionally. I will show you how to create such behavior. So how to create nothing? The most simple example is by infinite loop. Compiler can prove that this function will never end, so it's return nothing. Nothing can be returned from it. Also, there is function defined in a standard Kotlin library called todo. Todo returns nothing because it always throws not implemented error. There is also function from Kotlin Eclipse plugin called its method of class Kotlin logger called log and throw, which just logs an error and then rethrows it so it could be catched by some global exception handler. But how nothing can be useful? So the first example with when we don't want yet to specify whole function, but we want to use some expression inside of it, and we want our code to compile. In this example, we've got function calculating distance. We remember that we have to calculate square root of something, and we quite don't know what it should be. So we, for now, put here to do, and this code is proper Kotlin. It will compile, it will work. Of course, when you call this function, it will throw not implemented exception. The other one is from my project. You have some resources in project and you are in some method that you know that resource that you received belongs to some project. So you can just take a project object from this resource. It is nullable type, it is optional, so you have some way to handle this extreme unlikely situation that there is some bug and there will be null here. So you just use Elvis operator and then use expression, because log and throw method returns expression that can be used here. It will return something that is in type assignable to value project, because it returns nothing. But I am talking here a lot about throwing exceptions, but we are smarter than this. Kotlin is quite a new language. It has a better method of handling failures than just throw an exception. Exceptions are something that is really expensive to create. Filling whole stack trace is expensive reflective operation, and usually we don't even need this stack trace because most of exceptions should be handled locally in place of invocation of throwing function. So the first option is to use optionals when you don't care about any additional error info. It is quite common when you do some kind of batch processing of data. You've got many users, you processing in batch, so when processing for one user fails, you don't want to investigate why it failed. When it will be a common problem, then you could spend time on this, but sometimes failures happen, so you only want to provide some meaningful defaults or filter out these results. So this is function that handles these problems in that way. So it is function read user data that returns optional user data. It is called optional type. null can be assigned to this. It is exception. Normally, null is not assignable to Kotlin types. So we can use this in the following way. We read user data, then we can on optional type use just dot and use method name in this example process. We must use conditional invocation. It's question mark and dot. Then this method will be called if and only if read user data returns something that is not null. We also provide some safe default. So we again use Elvis operator that when something that is before it is null, it returns empty process data. So our process data is never null. So it's no longer optional type. You may say that it's the same stuff as Java optionals. But in Java, you can do this. And I once encountered code that a function that was returning in theory optionals was returning nulls because someone thought that empty null has quite different semantics than null. Empty optional has different semantics than null. But sometimes we care about not only return value, but also about cause of problem. So you can use sealed classes to deal with such situations. Here is an example of sealed class. It's called result. It got 3 children. The first one is called success and represent successful execution of given command. So it contains its data class. It contains user data as non-nullable field because we are 100% sure that if success was returned, then there is user data. There is some object user not existing, that's also children of result. We don't use here data class because we do not convey any additional information in this, so plain object is okay. And there is another data class representing failure, user data expired. It contains some information about date when that user data expired. So we can declare it as a return type of some function. In our example, it's request user data, and we can use it with when expression that was talked about by previous speaker. We've got 3 branches. In first, we kind of pattern match. If its type is success, then we can use some processing of user data. There is also branch when we checked if user data is expired, and another branch which is denoted as else, which handles all other kind of failures that can encounter. But let me step back a little. We've got this example with distance function when we talk about nothing type, and we can just change the first one to the second when to the other. We can replace to-do function with throw no implemented error, and we don't think anything around it. It's quite unusual, for example, in Java, when you can replace throwing an exception with calling a function. It's not only example when ordinary functions in Kotlin mimics behavior of some language constructs. For example, there is for loop over collection, and there is a method in collection class called for each. And this code is nearly identical. You can replace call of you can replace for loop with call of for each method without changing any code around it. There is also a repeat function in standard library that can replace old C-style for loop. Moreover, there are even functions in Kotlin that mix some behavior that in Java are implemented as language mechanisms, but in Kotlin they are ordinary function. For example, synchronized. The first example is Java. Synchronized is keyword. In the other, synchronized is just ordinary function that can be created by any Kotlin user and put in utils package in its product. But one might argue that in Java you can also have some functions that takes lambdas as arguments, so you can still in Java have for each and similar constructs, and it's nothing special in Kotlin. Of course, Kotlin lambdas are very smooth and clean, but you can do the same in Java. And one may argue that Kotlin lambdas has the same restrictions as Java ones. For example, that this piece of code, when we iterate over some list, some collection, and find one element satisfying our predicate, and we return it, it cannot be, for example, in Java done in for each, because you cannot, from lambda, return in some outer scope, because we want to return not from lambda, but from find long function. So one may argue that it's not the same, this function, as ordinary language control flow. Of course, you can do that in Kotlin. For example, this code, which is translation of earlier using for each, is 100% compiling proper working Kotlin. This is because for each function is so-called inline functions. Inline functions are never called when you see compiled class files. Their binary code is just waved into surrounding class file. So the lambda that begins in this brace after for each and ends before the second return, that lambda is never instantiated as any Java class or any Java method, is just inlined in bytecode. So this allows you to use your own defined control structures that behave the same or can even offer more than Kotlin control structures. And there are quite a lot handly inline functions in the standard library. That's few that are imported in by default in every Kotlin file they are available. And I really like them because all implementations of them is no longer than, I think, 10 or 20 characters. They are, you don't need any documentation or anything to use them, because only looking at their types you can clearly see what each one of them is doing. So let me show you the first one of it, called let. We've got some function written in what I called better Java. It is some example of using wonky API. I may be a little biased because I often must use in my work Eclipse API, so I've seen some strange things. So any wonky APIs are just my normal days, and I think a lot of you also works in some projects that even from Kotlin call some old Java APIs. So you must deal with all these strange behaviors and unpredictability. In this one, we've got something that creates request for some resource that may be located in some project. So our request object is created by first providing to them a list of paths. If the path to resource is absolute, then we don't need project path, but we need it if this path is not absolute. Then we add a resource path, then we do some string escaping on this list, and then we create a request object. Then there is some function that fills other data of this request and return it. So it's kind of convoluted, but first thing that I see here, that there is a lot of values or variables that live only for one expressions. They really don't need to have names in Kotlin, and I think it creates some kind of clutter, or you cannot see clearly what this function is doing top to bottom. And also there is something I quite don't like. It's we create a value, so it's something that is not immutable, but should be not replaced by something else. That is mutable list, and we've got some block later that initialize it. It's kind of not clear for me. I would prefer that I have a fully created object with data that I want in. So I can then assign it to value. This code is quite cleaner for me. So what is let? Let is inline function that it's extension function of all Kotlin types, so you can call it on absolutely any object. It takes block as an argument, so some function from type T to type R, and then return this R. So you call it this method on some object, it's pass this object to lambda block, and then returns what block was returned. And as you can see, there is one place when it is really useful. For example, we can eliminate value escape request data, because this return value of this map can be transferred at once to create request object. So from this we have something like this. It is quite better because it starts to look like some kind of pipeline. When you have map function, then you do something with its result, not that result of map is assigned somewhere and it is used in the very next line. But let is most often used for one of the most signature pattern of Kotlin. It is called optional let. So you've got example as one before, you've got some read user data function that return some optional result, but this time you have not a method of this object that do processing data, but some outside function that takes user data as argument. You cannot just pass what was returned from read user data to process user data, because the types don't match. One is optional, one is not, so we cannot just do that. The one way to do that, it's the better Java way, is to assign user data to some variable, then to check if user data is not null, then do processing, in other case return null, so you get some nullable result. But you can use let. And it's that short. You just read user data, then you use optional invocations. So if reducer data returned null, that nothing more happens, result is now null. But if it's not null, then inside of let block is called, so there is whole processing, so you can have optional result. So back to our example of request resource. There is another handy inline function in standard library called also. It is also defined as extension method for all Kotlin types. It takes block, but it returns unit, and so it is a Kotlin version of void. But it also returns the object that is called onto, so it's receiver. So when it is ideal to create some kind of side effects. So for example, we've got here in the line with fill other data at the end of this function, we've got some side effect because we have our request, then we do some side effect on it, then we return it. So we can just change it to this, and it's exactly the same because now we are returning what was produced by this pipeline, and also is a side effect that is invoked at the end. It is also used to invoke any kind of debugging or logging side effects into long-chained method invocations. So for example, we've got here some big builder that has many chained operation, but we want to print the state of this builder between second and third operation and between fourth or fifth. In Java, it will absolutely wreck this chain. You've got to create temporary variables and use print instructions, and it will no longer be expression. But in Kotlin, you've got also, so you can just plug also here, and this expression is the same expression as before, bar the side effect printing builder state. But back to our example, another useful function is apply. It can be used to make much cleaner this first part of function that I said I don't like it. It is often used as a pattern to initialize object. Often in Java and Kotlin, objects are created, but their state is not well defined. For example, in this, it is of course trivial example. You've got list that is empty, but you want to put in it these paths. So you must write another instructions that will add these elements to this collection. But with also, you can just change it to one call, because also it's also extension method of all types. It takes block, but this time this block doesn't take this something of type T as a parameter. It is take as receiver, so it can call methods of this type implicitly. So and it returns this type. So with this example, we've got this mutable list. Then we have apply block that is executed over this mutable list. We can see this add instructions that are add from this mutable list, and it is initialized, and then it is assigned to request data field. So we can just change it. So request data is no longer mutable list. We can create immutable list from mutable, because mutable list is inheriting from list. So we just in this apply block add this element, and when we return it, it is cast to immutable list. But we can also chain it together. So we can see that request data is another value that only lives through one expression. It is used in just next expression. So we can just do something like this. Then we can get rid of return keyword, get rid of braces. So our whole function is one expression. It is quite better, but it will be best if we extract this hairy part at the beginning and make a request resource just pure clean pipeline of operations executed one after another. This hairy part is nicely contained in some private funds, so it will be easier to maintain, and it has its name and stated purpose. But our request resource functions is now much cleaner. It also kind of looks similar to some kind of operation on reactive stream or something like that. You can, of course, interchange one with another. So, for example, if you want to do something like the last operation, this fill order data was done asynchronically, you can just change also keyword to async keyword, and it will work the same way. You can also plug here, for example, Eric's Kotlin streams or something like that. So you don't have one kind of code for normal processing and the other for stream processing. You can do everything like that. It is, I don't think it is doable in Java. Another little fun function that I want to show is run. It is something that has the same vibes as $operator in Haskell. $operator does something like this. It takes two arguments. One of them is function, the other is data, and it applies function to data. This does nearly the same things. It takes block as an argument and executes it. Just that. When block returns something, run returns this. It is surprisingly sometimes useful to refactor code. For example, in this case, you've got some class cache. It has some immutable field that is cached resources. But to initialize this field, we need some complicated logic. Here, it is quite trivial example. It can be easy inlined in this cache resource declaration, but it can be arbitrarily difficult and complex. And here we use init block. Init block is something that is not clean or nice. It has the same vibes as, I think, abstract class constructors in Java, which are really ugly and are rather to avoid, or static class initializer, which are even worse. So init block in Kotlin is some kind of hack when you need to initialize some variable during its construction, but you cannot do it as an expression. But here it is really, in larger classes, it is some kind harder to follow, because class in Kotlin often begins with list of its properties that are just expression defined in terms of other properties of this object and arguments of constructor. But here we've got some instructions that needs to be executed to just assign value to this field, but we can just use it run. So that fragment becomes this. You could argue that you may extract this logic to some private function and then call it. Yeah, it will be the same. But in the future, someone may maintain this class and want to use this private function to do some other things, because he or she don't understand some things, and thinks that this private function do something other, but he or she don't know that it can only be used during object initialization. So you have to write some comment like don't use this not during initialization, something like that, or you can just use a run function that creates function that has no name, that cannot be referenced. It is just inlined, so its result is assigned to value, and you cannot break anything with that. The other thing, the last thing today I want to talk about are contexts in Kotlin. I just skipped about it during talking about apply. So, as I said before, in apply, the something that is receiver of apply method, the something that is the something that is before the dot, becomes also a receiver of this block inside of apply. So you can call a method of this mutable list. In this example, it's add, as it is in your scope. So you don't need to reference this. This method are just in scope. It doesn't maybe impressive at the first sight, but it has some nice features. And there is even method with, which is another inline function, that just takes as a arguments receiver and block of code, and it executes this block of code in context of this receiver. So for example, you can write something like this. You have some user-defined config, and this user-defined config is receiver of all this block. So it is not some variable IP that is assigned, but a field of user-defined config. You may say that it's something like that was 15 years ago in Pascal. With blocks that brings all properties of structure to your scope, but this has really we can do much more with this. I will show you in a while, but I want to tell that this logic of context is often used in Kotlin standard library. For example, in coroutines. Here is I think the simplest coroutine builder signature that I can find that runs just blocking coroutine, and this has block that has coroutine scope as a receiver. So when we use it, we can just use variable from the scope. This is active variable is a field of coroutine scope defined by this block receiver, and we don't need to prefix it or something. It is not dependency injection. It is not passing it as argument. It is context that is vital to this function. But we can do much more with it, and this is really good example. It's something that after seeing that I really loved Kotlin. You've got some class trace, it got some mutable field that is string, and you also have a function that is extension method of string. It takes two string, concatenates them, and also log this information in field log. And you can see at the bottom in main function, you create the context with function. Then you can just call this method on string. So for example, in the first one, you can even use it as infix operator. And it is just code on these strings. These strings where they are in this context, defined by with function, then gain this method. And also, this method has access to field of context. So in this example, it will first print ABCD, then 1, 2, 3, 4, 6. Then when we leave this context, you get one last print statement that prints this log, and it will print both these traces of this operation as they were saved in it. It is really, really powerful tool. It is used, for example, for in standard library for generate sequence. It is a function that provides the same functionality that generator in Python has. You can just call in this block yields methods, and they will and produce sequence that is returned from this method will lazily evaluate and yields these results y bar 1. And this yield method cannot be called anywhere outside scope defined by generate sequence method. So it is quite like implicit in Scala, but in my opinion, it is even better because here it is not something that you import and it magically is in scope. You have to declare this scope, so it is kind of explicit implicit. You can also say that Groovy has the similar thing called delegation. You can achieve nearly the same result in Groovy, but in Groovy, when I copy one of this print line with concat inside and put it in just in main function outside this context, it will execute and it will probably throw null pointer exception because it cannot find context. In Kotlin, it is absolutely type safe. It is checked in compile time, so I just cannot use this concat method outside this context. Compilator will complain and it won't compile. Yeah. So at the first, I want to present much more examples and features. For example, more about companion objects, more about invoke operators, interface delegation, properties delegation, but this presentation was just as it is packed with information. So I can see we can, from here, think about some conclusions. A lot of stuff that I showed you is something that when used for a long time can change somehow the way you see problems. And you can see, at least from this few examples, few truths about Kotlin. For example, the first one is expressions are better than statements. You can do nearly the same things with expression that and you can do the same things with expression and with statements. And expressions are much more elastic, you can combine them easier. The second one is language constructs are not special. It is a godsend feature for any designers or domain-specific languages or something like that. And the last one is that scope does matter. And you can redefine what something means based on scope. It's not just for lexical purposes or for compiler, but it can actually have meaning for solving your problems. Of course, I'm not telling you that when you don't use these inline functions, don't use return types, you are a bad developer. No, you can be great developers without hearing about them. But they are tools that are there, and you can just pick and use them. And I guarantee you that after months and months, you start use them regularly, and it can change the way you think about problems. But let me get back to my digression from the beginning of the talk about Sapir-Whorf hypothesis. In 1983, Eckhard Malotki, that was German researcher that spent over 30 years living with remaining Hopi people and learning their languages, published a book called Hopi Time. In this book, he disproves the strong formulation of Sapir-Whorf hypothesis, and he cites many examples of how Hopi people can, in convoluted way, tell about time, and proves that they perceive time the same way as we are. So this whole hypothesis was kind of disproven now, but there is still soft formulation of it, that the language is changing the way you think about word by practice. For example, there are numerous experiments on people that was raised using languages that do not differentiate between light green and light blue, and they have hard times reading blue text on green background, and they do it a lot slower than people that was raised speaking Polish or English or any other languages that make this distinction, because in childhood their mind wasn't trained to differentiate between them. So I think it's the same in Kotlin. You've got some tools, and when you will be using it, and they are worth to be used, your mind will slightly change, and I think you will be better developers. Thank you.
You got some questions to Paweł about whatever he said is the best time, or later on when we like.
I got a question.
Oh,
About your last code example.
Yeah.
Could you show it for a moment?
okay, give me a second. This one?
Okay, so let's imagine there are more methods inside the trace class.
Yeah.
And could you just, for example, import not all of them, but some of them in the weak scope? Because, for example, there are some operators like some overwritten classes and other things.
Unfortunately not. Unfortunately, it's all or nothing. So when you intend to use this class as a context for some other calls, you must be careful about what you put in the scope, because all these things will be in this scope, so it can be sometimes problematic.
Okay, I ask this question because, for example, I see a situation where there is some other developer who works on the trace class, and he adds some method to this class, and there are existing scopes which use this class inside with.
Yeah.
And it can change behavior inside there.
No, because methods if string have method concat, it will have precedence over this, so it can never change behavior of the existing code. It can cause some problems when you change the code inside with block, but it is if you don't change it, it is guaranteed to not change behavior.
Scope.
Excuse me?
So basically, you take a scope like there with,
Yeah.
with trace, and just okay, I want only concat, nothing more. So I create yet another scope that takes the context as an argument, and just create a new context with fewer methods. Is it possible?
Yeah, it is absolutely possible, but you have to define your own context, and you can use interface delegation to delegate some of methods to
So
this.
there is some easy way to delegate from your own class to this, so you can just create a subset and
Yeah.
use it inside the group. Okay, so I think that's
It won't be this pretty, but it is absolutely doable, and it won't be long.
There is another one.
I didn't get this example with return 5. What happens on to the first slide.
Okay.
There's return 5 and the return type is nothing. This is understandable with throw,
Yeah.
but what happened with this 5?
It is return, because as you can see, the return type of function create is int. And this whole function create returns 5.
So this bar doesn't mean anything.
Yeah, this val with this over-the-top class name was a joke.
So this is the example of the code you shouldn't write.
Absolutely.
I've got one question, but this is like the best portion also. Waiting for yours. No? No? Okay. So I see that you like show us this really cool pattern when you can stack the operation and then like go or and then. So basically you don't need to create this intermediate values and so on and so forth. The question is how do you find debugging this? Because from my experience from Scala, when we got like a lot of nested calls and like especially in the collection, and you want to see what is the result of the collection after 3 steps. It's virtually impossible to get that. Is it like in Kotlin any better? Especially with all this really nice thing like let or else or also. Let or also, yeah, sorry, also.
Sometimes you do something like this.
Yeah.
You create also that just do nothing and set breakpoint in it so you can check the value of it.
Nice.
So it is one way of doing that. And all these operations are quite easier than Scala to debug because they are, I think I go too far, they are eagerly evaluated, so they are not lazy. Any of this operation is not lazy. So when you write apply, the whole this code is just executed in this time before you call them up. In this example, even map is called at once, and it's create a new collection because all stream operation or Kotlin collections are immediate by default. So you have to use a sequence operator to make them evaluate lazy.